Hi everyone, this is the video for lesson 4.3, similarity in right triangles. So I know you might not have your notes cut out yet, and that's okay. You can do it in class, and I will show you in class on how to tape and glue them down because they're a little weird. So first we're going to start talking about the geometric mean, and that is just a special formula that tells the relationship between two numbers, and this is going to relate to our geometry stuff when we get to our triangles. So the formula says that we have the number x such that x over a is equal to b over x when a, b, and x are all positive real numbers. And that's because these a, b, and x will represent side lengths on triangles, so they have to be positive. So if we play around with the formula a little bit and solve for x, we can end up getting this version of the formula, and that's the version I usually like to use because it's already cross-multiplied and solved for x, so it's easier to find x and you don't have to do as much work. So we're going to do the first example with the original formula and see what it's all about. So when we have two numbers, you can pick which one you want to be your a and b. It doesn't really matter, because they're going to times each other anyways once you plug them in. So I usually just go with the first one's A and the second one's B. So we'll plug in our formula. So we'll have x over 15 is equal to 20 over x. So once we plug in, we know that whenever we see an x, we have to solve for x. So to solve for x, we cross multiply. So x times x is x squared. Remember, it's not 2x. When you times those, you're adding their exponents. And then 15 times 20 is 300. How do we solve a quadratic equation where it just has an x squared and a number on the other side? Very good. We take the square root. So to get rid of the squared, take the square root of both sides. So we'll have that x is equal to the square root of 300. So whenever we have a square root like that, we're going to try to simplify it. Since it's not a perfect square, it doesn't come out to be a whole number. There's going to be some stuff left over inside the radical. So we practiced doing this on our summer homework. I know that was a long time ago, back in August. There's a couple different ways you can do it. One of them is using a factor tree, where you find all the couples, remember, that are going to prom, and we circle them. So split 300, and you can break it up into whatever factors you want. I like to start with the smallest number that goes into it and keep dividing by the smallest number for that factor. So 2 is the smallest thing that goes into 300. 2 is the smallest thing that goes into 150. 2 doesn't go into 75, so the next number would be 3. And then 25 is 5 and 5. So once we have all of our factors, we look for the pairs that are the same since it's a square root. So we have a pair of 2's and a pair of 5's. So remember, we like to think of them as couples going to prom, so they have to be the same number because they're dressed alike for prom. So we have one couples of 2's, so we put 1 2 out there. And we have one couple of 5's, so we put 1 5 out there. And that poor lonely 3 doesn't have a prom date, so it has to stay home inside the house. And then after that, we multiply the numbers we had on the outside. So our final answer is 10 root 3. So that's the geometric mean of 15 and 20. So why don't you go ahead and pause your video and try example 2. Okay, welcome back. So I used, for my example here, the other formula, the one that said x equals the square root of a times b, so I wouldn't have to do the cross multiplication, but it's totally okay if you did. You should have ended up with that x equals the square root of 72. Make your factor tree. You get a couple of 2 and a couple of 3's with that lonely 2 left inside, so your final answer should have been 6 root 2. Okay, so let's take a look at our triangles and talk about how this relates to what we're actually learning today. So we have a new theorem, and it says that the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original and to each other. So what this is going to do is break up this big right triangle into pieces, and then we'll have three triangles, the big one and the two smaller ones, that are all similar to each other. Okay, so it says that it splits from the altitude to the hypotenuse. So that would be the line that goes straight down from the right angle we already have to the hypotenuse. So if we take our little pieces of triangles, put them on top of that big one we had, we can see that CD is our altitude. That line right there, CD. And it's splitting that big triangle into these three pieces. So the big original one, the medium-sized one, and the baby-sized one. Okay, and those three triangles are similar. So that means that their sides are going to be proportional, and we can write proportions in case we're missing a side length. So when you're doing this and you're writing your proportions, sometimes it's hard to see where the pieces go because you're going to have to make your proportions out of the side lengths, and our pictures are going to look like this. So as we can see, we have some variables in different spots. Sometimes we have numbers in other spots. So we're going to take our original triangle and split it into the three triangles, the big original one, the medium one, and the baby one. But we're going to have to label each side to see which sides go together to see how we would write our proportions to solve for x and y. So let's look at our cutout ones because that'll help us see how they end up rotating or reflecting and how we'll be able to match up the sides. So what we want to do is to be able to have all three of those triangles turned and orientated the same way. So if we look at our big original triangle, our right angle is placed in the top and our hypotenuse is in the bottom. So to make this one turn the same way, where the right angle is in the top and the hypotenuse, the longer side, is in the bottom, we have to actually flip it over the hypotenuse of that side and then turn it just a little bit and it'll be the same. So now the right angle's on top and the hypotenuse is on the bottom. So we'll do the same thing here. If we flip it over its hypotenuse and turn it a little bit, now we have all three triangles turned the same way. Okay, and that will help us write our proportions because we can see that the corresponding sides are in the same spot. So let's try that with our examples. Okay, so for the first one, I drew your three triangles for you. Normally when you start these problems, you'll have to break it apart and draw three triangles. So it doesn't matter if they're exactly the same size as the ones in your picture. All you need to have is three, and make sure you have a big one, a medium one, and a small one. And it would also help if you make sure you draw those two sides where they are distinctly different sizes. Even with this one where they look like they're going to be the same or very close to the same size, I would draw them or try to draw them where they're different so it's easier to match up the sides. Okay, so before we actually start doing this, I want to highlight the different triangles so we can see the big one. So I'm going to highlight this one, and that's going to be my baby, so my yellow triangle. And then the medium one will be my pink triangle. So this will help us when we're talking about them. We'll know which one we're talking about. Okay. It's also important to remember that since this is a right angle, we have a right angle here as well. Okay, and I'm going to draw in my right angles where they go in the bottom pictures. So now we need to label the sides to be able to make our proportion. So we'll start with the big one. So the big one, we can find the hypotenuse the easiest, so we'll always start with that side. So this is our hypotenuse, and it's broken into two pieces, this yellow piece and this pink piece, but all together, it's the hypotenuse of the big one. So we would add those numbers up. So 4 plus 12 would make our hypotenuse 16. We're not given a value on this side, so we'll leave that side blank. And then we're given the bottom is x, or the little side is x. Okay, so we got our big triangle. So now take a look at your medium-sized one, the pink one. So if we look to the hypotenuse has nothing labeled. So that means we'll leave this hypotenuse down here blank. The big side would be over here with 12. and then the little side is y. So remember I talked about flipping it over and rotating it, so you would see that the y would be over here and 12 would be over here. Okay, so next is our yellow one. So for this one, if we look across the hypotenuse, we do have a hypotenuse measure or labeled of x. The little side down at the bottom is 4, and the longer side is y. So once we have our triangles all set up and labeled, then all we have to do from there is write proportions to solve for x or y or both. So I'm going to start with x. If we take a look in this first triangle, it has a number and an x. So I'm going to use those sides to find a proportion for x. If I have a pencil or x. Okay, so we have these two sides that go together. 16 over x will be half of our proportion. So what we need to do now is find another triangle that has those two same positions labeled that has an x in it as well. So if we take a look at the middle triangle, this side has a y, so we know we definitely don't want it, but there's nothing on the hypotenuse. So now move on to the small triangle. We have the same two sides labeled, and there is an x and a 4. So we know we're good. We don't have any y's in there. So now that we wrote out our proportion for x, you can see that the geometric mean is important for this because this is the geometric mean. It has an x in the bottom of one side and the top of the other, just like what we looked at on the front. One note before we get too far in this, that sometimes your geometric mean, like the things that are across from each other, they might be here, or they might be not x's, they could be numbers. So it could be 16 and 16 and x and 4, or some other variation of that, but it doesn't always have to be the variables that are repeated. So we'll solve this one real quick. Cross multiply, we get 64 equals x squared, and we won the lottery on this one because 64 is a perfect square. So just take the square root of both sides. The square root of 64 is 8. So we found x. So now all we have to do is write another proportion to be able to solve and find y. So we got no y's in this one. So we move on to the next triangle and look for a y. So here we have a y on the bottom, and then the only number is on the altitude or the long side. So we need the other triangle to have a y and a number in those same positions, and it does. So there's our y proportion. So 12 over y equals y over 4. If we look, it was 12 over y equals y over 4. So do the same thing. Cross multiply and divide to solve for y. So 48 equals y squared. So y would equal the square root of 48, which you have to break down. Go ahead and make a factor tree. Pause your video. Okay, so it ends up being 4 root 3 after you make your factor tree. Okay, if you have any questions, make sure you write them down to be able to ask in class tomorrow. So I'm going to draw the pictures with you, and then you'll pause to finish the next example. So this one is turned different than the first one we did. So when you draw your triangles, turn them the way the original one was drawn. So I'm not going to draw them like I drew these ones because this one was drawn differently. So I'm going to draw these with the hypotenuse across the top and the right angle down at the bottom. So like I said, they don't have to be exactly the same as your original, and you know my drawings are never that great, but as long as we can see where they go, then we're good. Okay, so in our original one, that's the big one here, we can see that the hypotenuse is this side up at the top, so it's broken into pieces again. Add them up. This right side got nothing, and then the left side is x. Okay, so I'm going to call this one my medium triangle. Is there anything labeled on the hypotenuse of that medium triangle? Very good. We got nothing here. So now we need to figure out which of these goes in those spots. Okay, so one way to do that is to reflect it like what we talked about when we looked at our pieces. So if we turn it, we have our hypotenuse. You can kind of sketch what it would look like if it's flipped over. So if it's flipped over just like that, what side ends up being right here when it's flipped? Good, the Y goes right here. And then the 5 would get flipped right here. So we can see that the left side of the right angle is Y and the right side of the right angle is 5. So if we go back to our separated triangle, the left side is Y and the right side is 5. And if you look at this one when it's turned, you don't really even have to flip it because you can see the left side is Y and the right side is 5. Okay, so now let's look at our small triangle. So does the small triangle have a hypotenuse? Remember, the hypotenuse is the side that's across from the right angle. So we can see that that side is labeled X. So if we turn, we get the left side is 4 and the right side is Y. Okay, left side 4, right side Y. Once you have all your pictures drawn, then you can write your proportions. So go ahead and pause your video and try to write your proportions. When you come back, I will show you the answers. Okay, so let's take a look and see what we came up with. My proportion that I wrote for X was 9 over X equals X over 4. 9 over X equals X over 4, cross multiplied, and we end up with 6 because we have a perfect square. So now we're looking for Y. So we have no Y's here, so move on to the next one. We have Y over 5 equals 4 over Y. So cross multiply, we have to make a factor tree, and we end up with 2 root 5. Okay, good job, guys. So I am going to do the third example in another video. I'd like you to try to complete it on your own first. Be careful with this one. If the whole thing's 50, what does that leave for this if that spot is 40? Okay, so go ahead and try that one and check the other video for the solution. Werner out.